When we look at the moon and we look at its composition, that is going to give us a clue to how our moon formed. Now, prior to landing on the moon, there were 4 main hypotheses of the moon's formation. So we're going to look at each of these and then compare this to what we now know about the moon. Early in the 20th century, the first main idea for the moon's formation is called fission. And the picture illustrates the idea behind fission. That here we have the forming Earth, and it's rotating on its axis. And at this stage, Earth is still molten. So the idea was to picture this molten blob separating off from the Earth and becoming our moon. Now, this predicts, because the Earth and Moon are forming from the same material, that you should have identical composition. Now, what we observe when we look at the moon is that the moon is similar to Earth's crust and mantle, but a lot less iron, which is found in Earth's core. So just based on that alone, that eliminates the fission hypothesis. There's another good reason to eliminate the fission hypothesis that was later determined. This is physically impossible. Molten blobs do not separate off of forming planets. The gravity of the planet would not permit that. So fission definitely eliminated. So fission has been eliminated. Our next hypothesis is the sister, or also called the co-formation hypothesis. And in this case, we can picture the Earth and Moon system as being a smaller version of the formation of the solar system. So Earth is forming, it's pulling material in, but it has this disk of material that has developed out of the material that was forming into the Earth. And the material in that disk starts to clump together, and accretion occurs, and that builds up into our moon. Just like with the fission hypothesis, this again is going to predict an identical composition, because that material in the disk around the forming Earth is going to be made of the same material that actually got used to make the Earth. And as we saw before, our observed is that it's similar in composition, but not identical. And so once again, we can eliminate. So sister or co-formation does not apply. However, this does apply for the larger moons of the Jovian planets. So although not the case for our own moon Earth system. It is true for Jupiter, Saturn, Uranus, and Neptune, and the larger of their moons. This is likely how they formed. So possible, just not likely for our moon. Another possibility is that the moon was captured. Now, in the capture hypothesis, the moon would have formed somewhere else in our solar system, and it took a trajectory that brought it in near the Earth, close enough for Earth's gravity to grab hold of it and pull it into orbit. Now, in this case, because the moon would have formed someplace completely different, this would predict a completely different composition from the Earth. Again, what we observe is similar but not identical composition. So once again, our observations eliminate this hypothesis. Again, this is physically possible. The smaller moons of the Jovians plus Mars's moons are all thought to be captured. But typically, in this case, what you need is a moon much smaller than the planet. And our moon is, reasonably good sized compared to the Earth. It's just a little too large for us to capture. A small asteroid, like the moons of Mars, that we can capture. The Jovian planets capture comets and asteroids, and smaller things, yeah, you're going to be able to capture those. Something as large as our moon probably are not going to be able to capture it. So capture hypothesis is eliminated. Our last hypothesis is called impact. Prior to landing on the moon, the sister or co-formation hypothesis was the most popular. Impact was not given much credibility. The idea behind this hypothesis is that early in the solar system there were a lot of protoplanets that ended up not getting used to make planets, did not survive, and there were lots of collisions. So the hypothesis is that an object about the size of Mars collides with the Earth. That collision knocked material off of the Earth. Now, because Earth was mostly molten at this stage, it was able to reform itself into a nice round shape. And the material that got knocked off, most of it went into orbit around the Earth. And so Earth had this kind of ring of material, very much like the sister formation. But instead of being present as Earth formed, it's present now after Earth has formed from material knocked off. And that coalesced and turned into our moon. So the prediction for this hypothesis is that it's going to be similar in composition, but not identical. because the impact is going to generate a lot of heat, the moon should lack materials that vaporize easily. Well, when we went to the moon and when we looked at the moon rocks, we found that the composition is similar but not identical to Earth. And looking at the abundances of different materials on the moon has a large percentage of materials that survive high temperatures and has a definite lack of materials that vaporize easily. And so, because of our evidence from the moon landing, this hypothesis that wasn't taken seriously originally is now our accepted theory. And looking at other moons in our solar system, we also think that this is how Pluto's moons formed. So it's not just us, but also Pluto, that have moons as the result of an impact.